This is part 3 of the homework video guide for the chain rule, and for this section we're now dealing with composite functions. So if I want to take the derivative of y equals to f of g of x, my derivative will start on the outside function here, so I can write y prime equals to, now the derivative of f is going to be f prime, and then everything remains the same, and then I'll write the g of x in a different color there. So everything on the inside remains the same, and then you multiply by the derivative of the inside, and the derivative of the inside, well, the derivative g of x is just g prime of x. And that's your derivative for question number 1. So we start on the outside, and then we take the derivative of the inside. All right, let's move on to question number 2. For question number 2, this derivative might be a little bit easier than the first question. So I have a 3 there, so that 3 gets soccer kicked to the front by the power rule. And then everything remains the same inside the brackets, and then the power decreases by 1, which is 2. And then I multiply by the derivative of the inside, so the derivative of f of x is just f prime of x. And that's it for question number 2. For question number 3, the outside function is f, so that's where the derivative starts. So y prime equals to f prime, bracket, and then the x cubed remains. And then I can close that bracket. So that's the derivative of the outside part. And then the chain rule states that you need to take the derivative of the inside part, and the derivative of x cubed is going to be 3x squared. And there's your derivative for question number 3. For question number 4, we have a little bit more work to do for question number 4 here. So I have an outside power here, so that gets soccer kicked to the front. So 3 in the front. And then now we just write everything the same on the inside here. And that gets raised to the power of 2. And then I need to multiply by the derivative of the inside. So here's my inside. And the outside part is this f function here. So if I multiply by the derivative, that's going to be f prime. But then everything else remains the same, right? So bracket x cubed plus x, close the brackets. All right, so that right there is the derivative of f. And then we multiply by the derivative of the inside of x cubed plus x. And that's going to be just 3x squared plus 1, and then I just close the bracket. All right, let's move on to question number 5 now. So for question number 5, I will start by rewriting this as a power. So bracket, and then everything on the inside remains the same. All right, so we're not taking a derivative here, we're just rewriting it as a power here, so power to 1/2. And now let's take the derivative. And this 1/2 gets soccer kicked to the front, so 1/2. And then everything remains the same. Actually, let me just use a different color here. I'll go back to blue here. So bracket, and then f of x minus 3x. And then I close the bracket there, and then I minus 1 from the power. So that's going to be negative 1/2. And then I multiply by the derivative of the inside. So what's the derivative of this? Well, let's put a square bracket there. That's going to be f prime of x, and then minus 3, and then I can close the bracket there, and that should be it for that particular question there. I actually won't bother to simplify this one here just to kind of save time on the homework video guide. Question number 6 here. Question number 6, this is kind of a weird one here. If I rewrite this, this is really y equals to 1 over, and then this part right here, that really just means that f of x, all of that is being raised to the power of 2. Okay, so that's how you would rewrite that particular question there. And if you want, I would rewrite this one more time as y equals to bracket f of x, and then close that bracket, and then let's raise this to the power of negative 2. All right, now this derivative is much easier to take, so let's go ahead and write y prime equals to. All right, so the negative 2 gets soccer kicked to the front. I'll just stay in the black color here. I won't change colors there. And then I can subtract 1 from the power there, so that's going to be negative 3. And then I multiply by the derivative of the inside, which is just f prime of x. All right, so that's it for question number 6 there. And now let's move on to question number 7. For question number 7, we can rewrite this as y equals to f of x, and that's being raised to the power of negative 1/2. So very similar to the previous problem here, I can take the derivative now. So the negative 1/2 comes out to the front. And then the f of x can remain the same. And then I just subtract 1 from the power, so minus 2 over 2. So that gives me negative 3 over 2. And then I just multiply by the derivative of the inside, which is just f prime of x. All right, so I'm not going to bother changing this back into radical form here. I'm just going to just simplify this as best as possible there, and that's it. All right, question number 8 here. Okay, so we have a product rule here. So I have this, and I'm also multiplying by all of that. All right, so this is going to be a bit of a tough one here. So let me kind of rewrite this as y equals to 3x squared multiplied by f of bracket g of bracket, and I'll write this as x to the power of 1/2, and then I'll close that bracket, and then I close that bracket. All right, so now we're ready to take the derivative here. So I'll start by writing out y prime equals, and then we take the derivative of the first term, and the derivative of the first term is going to be 6x, close the bracket, and then multiply that by everything else. And then the product rule states I need a plus sign there. All right, so then I can add, I can add the first term, which is 3x squared, multiplied by, all right, now this is the challenge here. I need to take the derivative of this here, this expression right here. So we start with the outside power, which is f, right? So let me kind of erase this again. So we want to start with this outside power there. So that's going to be f prime. And then everything remains the same inside the bracket. So f prime of g of x to the power 1/2. Close that bracket. And then I need to multiply by the derivative of this inside. So then the outside function now is just g. So I multiply by g prime, and then everything remains the same. And then I multiply by the derivative of that inside, which is just 1/2 x to the power of negative 1/2. All right, so that was pretty crazy right there. So that right there is the final derivative, and I will not simplify this just because it just takes quite a bit of work and effort there. So I think that's totally fine to leave the final answer like that. Okay, so we move on to question number 9. Question number 9, this one's a little bit easier here, so I don't need to rewrite anything here. So y prime equals to, all right, there's a 4 here, so if I soccer kick that to the front, I get a 12. And then I have bracket f of x squared plus 2x, close that bracket, and then if I minus the 4 by 1, I get a 3 there. And then I can multiply by the derivative of the inside here. So the derivative of f of x squared is going to be f prime, and then everything remains the same. And then I times by the derivative of that inside, which is going to be 2x. And then finally there is a plus that derivative, and the derivative of 2x is going to be 2. And then close that bracket there. Okay, so there's a derivative of that particular expression there, and I don't think I'll simplify this any further here. That looks pretty decent to me. Okay, so move on to some table questions, and then we'll finish off this homework guide. All right, so classic, we get these classic table questions again, and for the very first question, I guess we have a product rule. We have x squared times f of x to the power of 4, and I need to find f prime of 1. Okay, so let's go ahead and let's see if we can take the derivative of this very slowly here. So this will be f prime of x equals 2. Now the derivative of x squared is going to be 2x, so 2x times f of x to the power of 4, and then the product rule states that you need to add, and we're going to add x squared, and then we're going to times it by the derivative of f of x to the power of 4, which is f prime of bracket x to the 4. That all remains the same, and then you multiply by 4x cubed. All right, so that's the derivative right there, and now we can go ahead and calculate f prime of 1. All right, so what that basically means is that all the x's here, all the x's get replaced with the 1, right? So 2 times 1 is going to be 2, and then this will be f of, and 1 to the power of 4 is going to be 1, plus, all right, now we have x squared, so x to the power of, 1 to the power of 2 is going to be a 1, times f prime of, well, 1 to the power 4 is going to be a 1. And then finally I have 4 times 1 to the power 3, which is going to be 4. Alright, so now we need to kind of finish this off if we can. So I have a 2 here. Alright, so what's f of 1? So here's f, and there's 1, and f of 1 is going to be 2, right? So f of 1 is going to be 2 plus 1 times, and then what's f prime of 1? Well, f prime of 1 is going to be 4. So that's going to be times by 4, and then times the last part by 4. Alright, so if we multiply this out, we get 4 plus 4 times 4 is 16, and 4 plus 16 is going to be 20. So the final answer there is going to be 20 for that table question. Okay, let's move on to the next table question here. Okay, I need to find g prime of 4. So here is my function here. So let's go ahead and take the derivative. So g prime of x equals 2. Now the outside function is g, right? So that's going to be small g, so g prime, and then everything remains the same. And then we take the derivative of the inside here, and the outside function is now f, so that's going to be f prime of x. Perfect, so there's my derivative right there. And now I need to figure out what g prime of 4 is. Okay, so anytime you see an x, all the x's will be replaced with the 4. So this will be g prime of bracket f of 4 times f prime of 4. Okay, so let me kind of erase that and erase that. Okay, and then let's go ahead and figure out what's happening here. So what's f of 4 here? So f of 4, so here's f, and there's 4, so f of 4 is 1. So what I have now is I have g prime, and f of 4, we found out that that was just 1, right? So this will be bracket 1. And then we multiply that by, then I have f prime of 4. Okay, so here's f prime, there's 4, so f prime of 4 is going to be negative 2. So this will be negative 2. Alright, and then finally, the last thing that we need to calculate here is, let me erase all this. I need to calculate what g prime of 1 is. G prime of 1. Well, here's g prime, there's the 1. G prime of 1 is going to be negative 3. So this will be a negative 3 times negative 2, and that's going to be a positive 6 there. Right, so that was a pretty tricky question there. We got to be pretty good with our derivatives when we're dealing with the composite functions here. Okay, just a few more to go here. Let's go to question number 3 here. So now the composite functions are getting a little bit more complicated here. So let's write out p prime of x equals 2. All right, here's my outside function, right? So that's going to be f prime, and then everything remains the same. And then the chain rule states that you need to multiply. Now I need to multiply by the derivative of this inside. And the way that starts off is that this g is the outside function. So g prime, and then everything remains the same. And then we take the derivative of 2x minus 1, which is going to be just 2. Alright, so there's my derivative right there. And now we need to find p prime of 1. Okay, so what that basically means is all the x's will be replaced with the 1, right? So there's an x here, there's an x there, right? So let's see if we can deal with that. So this will be f prime of bracket g, and then g of what? 2 times 1. So right here, 2 times 1 is going to be 2, and then 2 minus 1 is going to be 1. So that's g of 1 times it by g prime bracket, and once again, if we put a 1 here, 2 minus 1 is going to be a 1. Close that bracket, and then I multiply this by a 2. Okay, there you go. Let me see if I can just erase some of this here. Okay, so now we need to go to the table here. Let's start off with the g of 1. Where is g of 1? Well, there's g, and there's 1, so g of 1 is going to be 4, right? So if we continue here, this will be f prime, and g of 1 was 4, right? And then we multiply that by g prime of 1. Where's g prime of 1? Well, here's g prime, there's 1, so g prime of 1 is going to be negative 3. So I multiply that by negative 3, and then I also have this 2 that's hanging around there. Alright, let me erase the colors here, and then finally, what's f prime of 4? So here's f prime, there's 4, f prime of 4 is going to be negative 2. So this will be negative 2 times negative 3 times 2. And if we multiply all that together, what do we get here? Is that 12? Positive 12? Yeah, positive 12. Good. Okay, I think we have one more question to go, and then we're done this homework video guide here. So one more table question here, and we're given this weird composite function, and we need to find q prime of 1. All right, so here's q. Whoops, that's not a q. So q prime of x equals 2. All right, so here's my outside function, so f. So that'll be f prime, and then everything remains the same on the inside. So 3x minus f of bracket x cubed, close that bracket, and then close that bracket. And then the chain rule states that you need to multiply by the derivative of the inside here. Okay, so the derivative of 3x is going to be, let me put a square bracket here. So the derivative of 3x is going to be 3 minus, and then here's my outside function, so that's going to be f prime, and then everything remains the same on the inside. And then I multiply by the derivative of that inside, which is going to be 3x squared. And then close the bracket like that. Okay, so there's my derivative there, and then now we need to calculate q. Sorry, that's not a q, it's theta, so q prime of 1. Okay, so let's go ahead and plug in 1 for all the x's here. So now I have f prime bracket, so 3x, so if I plug in a 1 there, so 3 times 1 is going to be a 3, minus f of, and if I plug in a 1 here, so 1 cubed will be just a 1, right? So f of 1. Close that bracket and close that bracket. Actually, maybe I'll just put this, maybe I'll just change the colors here. So I'm not sure if that was clear. So bracket and a bracket. And then times, and then let's open up a green bracket here. So 3 minus, now if I plug in a 1 here, that's just going to be f prime of 1. And if I plug in a 1 here, that's going to be 3 times 1, which is going to be 3. And then close that bracket off. Okay, let's see if we can start figuring out some numbers here. So what is f of 1? So f of 1, so here's f, there's 1, so f of 1 is going to be 2 there. So if I keep on going here, this will be f prime of bracket 3 minus, so f of 1 was 2. And then we multiply that by square bracket, there's a 3 minus, and then what is f prime of 1? Well, here's f prime of 1 is going to be 4, right? So f prime of 4 is going to be 4, sorry, f prime of 1 is 4, and then we multiply that by a 3. Okay, so we're almost done here. Let's see if we can just figure this out. This is f prime, and 3 minus 1, sorry, 3 minus 2 is going to be 1. Multiply that by, well, we have 3 minus 12, and 3 minus 12 is going to be 9, I guess. So this will be f prime of, actually, hold on. Let's just find out what f prime of 1 is. Okay, so let me just erase this. Here's f prime, there's 1, so f prime of 1 is going to be 4. So this will now be 4 times 3 minus 12 is negative 9. And 4 times negative 9 there is going to be negative 36 there. Okay. So there you go. There's the last answer for that particular problem. That was pretty long there, but hopefully the composite rules weren't too bad.